Everybody, it was a little technical issue with the first video, so I just gonna submit the voice explanation here and show what I did just without drawing it. I'm also gonna submit the drawing video because I think it's important to have both as proof that I did it. I was like 20 minutes talking to myself because I forgot to turn on the mic. So let me just show you what I did, okay? We go to files here, recent, untitled PNG, and here we got polyatomics oxyacids. So we go to here. Okay. So I choose to do H2SO4 or I think it was sulfate, sulfate acid, if I'm saying correctly. So I start by drawing the center atom here. That was sulfur. Then the four oxygens around and the four H's around. Originally, it was single bonded here and single bonded over here. And it were two more protons on the oxygens on the top, and oxygens on the bottom. So okay, now be that here got the equation for these exam numbers. So sulfur would have been 2 plus, and oxygen would have been minus 1, minus 1. But I'm trying to make the best Lewis structure, so I have to get this to 0. So you just eliminate a set of electrons, and you add it as a bond. And after you do that, you just calculate everything as you can see here. 6 bonds electrons, 6 bonds minus 0, that would be 0. Oxygen is equal to 6 bonds electrons minus 2 bonds minus 4 electrons, that would be 0. So this will be the best possible extraction with 32 bonds electrons. Then you go to HSO4. So what I did here was just simple. I just copy and paste this Lewis structure, just removing the hydrogen because to become a base you need to lose a proton. A proton is always gonna be the hydrogen as far as we know. You lose a proton but you keep the electron. I mean you become negative. That's what is the negative shaft here on the top. So you have to add that electron somewhere, which better than the oxygen that was paired with that hydrogen. So you just add an extra electron to the oxygen. That will be this guy. And then use the calculations. Sulfur, 6 bonds electrons, minus 6 bonds, minus 0 loose electrons, that's 0. Oxygen, 6 bonds electrons, minus 2 bonds, minus 4 loose electrons, that would be 0. Oxygen, minus 6 bonds electrons, minus 2 bonds, minus 4 loose electrons, that's 0. Hydrogen, 1 valence electron, minus 1 bond, minus 0 loose electrons, that would be 0. And the new oxygen, that is 6 valence electrons minus 1 bond minus 6 loose electrons, that's negative 1. The negative 1 along with our charge over here. So you put it between parentheses and the negative charge. After that, I decided to move to my second polyprotic oxyacids. I don't like that word, it's so hard to pronounce. And here I just did the same. Write the normal formula, find the valence electrons, blah 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 blah. That's 24. Let's eliminate this again. Turn to a normal state. That'll be this state. Okay, so we got 24 balanced electrons. Here are the questions to demonstrate it. 1 minus 1 minus 0 is 0. 6 minus 2 minus 2 minus 4 is 0. 4 minus 3 minus 0 is 1. So this will be plus 1. And 6 minus 1 minus 6 is negative 1. But you need to find the best possible structure. So you just readjust this. That means the negative 1, those are pair of electrons. And it gives it to himself and carbon. So you just redo the calculation for the carbon and this oxygen. So I mean 4 minus 0 is 0. 6 minus 2 bonds minus 4 bonds electrons, 4 loose electrons is 0. So that's perfect. Then you want to make it a base. So again, just take the hydrogen away. Just take it away because you lose a proton, become more negative, gain an electron. Typical of a negative because you have a plus negative one. You have to add that electron to molecule and you have to add that electron to an atom right here, which atom that the oxygen that the hydrogen was bound with. So just calculate everything again. One valence electron minus one minus 0 is 0. 6 valence electrons minus 2 minus 4 is 0. 4 valence electrons minus 4 pairs minus 0 loose electron is 0. 6 valence electrons minus 2 pairs minus 4 lone electron is 0. And the new guy, 6 valence electrons minus 1 bond minus 6 loose electrons, that's negative 1. The negative 1 here aligned with the charge over here. Put it between parentheses at a negative side and you have it. The best possible lucidity for the acid and the base. And if we need to exponential why uh, this lose an electron is to get to a more, I think, stable energy, if I'm remembering correctly. Not sure, not too sure in that part. Okay, bye bye.